Hello and good afternoon, ladies and gentlemen, and welcome to FARO's webinar on the new version of Photoplan 16.5. My name is Jana Siebenbrot. I'm the Technical Product Manager of Photoplan, and I will guide you through today's webinar and the presentation of the software. Before I start with the software presentation, some housekeeping. While I'm presenting, you may ask questions, type your questions in the question bar, in the question window of GoToWebinar, and you can see here a list of dial-in numbers just in case that your voice over IP is not available. You need to type in the following access code over here. So before I introduce the software Photoplan to you, let me just introduce our company. Photoplan has been developed by FARO 3D software. We are a software vendor located in Dresden, Germany. The company has been founded in 1999 as Qubit GmbH. And since March this year, we are part of the FARO Technologies company. Here in Dresden, we are about 30 employees, and we offer AutoCAD and Revit-based plug-in solutions, as well as standalone software for different fields of application. And our products do stand for accuracy and efficiency. So let's start with the question, why would people need a software like Photoplan? So as you may know, digital photos are taken very fast and easy, and they do contain very detailed information, but they are distorted by perspective view, and thus we cannot take any direct measurements of distances or areas from those photographs, but we would like to have those. And therefore, you can apply a Photoplan to get geometric information. So Photoplan is an AutoCAD plugin for creating accurate geometric data from digital images. And with Photoplan, you can create true to scale, undistorted photographs to use them as image plans. You may also create oriented images, which are just an intermediate result for using them as for multiple image photogrammetry. From those oriented images and surfaces, you can derive ortho images or image plans unwrapped into the plane. And all this, as already mentioned, can be created directly inside AutoCAD. Photoplan is used by people in the field of building design and architecture in order to create facade plans for modification and reconstruction, or to create 3D models of buildings. Also, historical preservators may use Photoplan for as-is documentation and stone-by-stone drawings, as we can see here, or to create damage maps of facades, or to model historical buildings. Archaeologists are using Photoplan for excavation documentations, but also law enforcement uses Photoplan for accident crime scene documentation or suspect height determination. Now let's have a look at the features, at the functionality of Photoplan. Photoplan, we have 4 different modules of Photoplan, which are based on each other. So let me start with the smallest Photoplan package, which is Photoplan Basic. Photoplan Basic does give you the opportunity to rectify images by distances, and in addition you can apply lens distortion correction. You need this in order to be able to rectify those images correctly, and you get also tools for dimensioning areas and elevations inside the rectified image. The image rectification by distances works in a way that we provide a rectangular grid which we need to apply and adjust to the photograph like this. So horizontal lines, parallel horizontal and vertical lines in the photograph must then line up with the grid, or the grid has to line up with those lines. And then in addition you need to have at least 2 true length measurements for a distance in the photograph, and then the algorithm will give you the rectified image, and you can clip that image in advance so you get rid of those areas which are not of interest. And then you are able to measure inside this rectified image. The lens distortion correction is needed in order to remove distortions which are caused by the lens. Those lens distortions, they lead to images like in the sketches on the right-hand side, which make straight lines on the object curved. And our lens distortion correction removes those distortions, and then it's easier also to apply this rectification grid I've talked about earlier. And once you've rectified the photograph, you can complement your image plan by dimension annotations and elevation annotations. So these are the features of Photoplan Basic. The next larger package of the Photoplan family is Photoplan. It does contain all the functionality of Photoplan Basic, plus additional features like image rectification by control points. This method is much more accurate than rectification by just some distances. And it also provides you possibilities to rectify scanned maps. And you can also merge photographs into a mosaic. And we provide you with some export tools into VRML or into Esri World files. The image rectification by control points works in a way that you have to measure control points by a total station, then you read them into AutoCAD Photoplan, and then you assign those control points with the according points in the photograph, and our algorithm will calculate a rectified image out of those control points. And here's where I want to demonstrate how this works with our software. So let me just switch to AutoCAD. Here we have got the magenta colored symbols. Those are the control points which I've read in. They come from a a total station measurement, and you can see they are distributed in 3D, but all on certain main facade planes. So they are in one, the control points for one photograph, they are in one rectification plane. So let me switch to let me switch to the top view here. Okay, so I've already set the rectification coordinate system to those control points. I have a photograph here which needs to be rectified. I'm only interested in the facade, not in the sky, and also not in the roof. So therefore, I will go in here and clip the photograph. Okay, so I have to select it first, then select the points option, and we'll clip the photograph to the area of interest. So the algorithm doesn't need to calculate rectification of pixels which we are not interested in. So first I clip the image and finish this. And now I can run the rectification by control points command. I select my image and I will now assign the control points. I'll select the control point first and then I zoom in to the area in the photograph where this control point is located. Do the same for at least 4 more control points. They need, as I mentioned, they need to be all in one plane for the rectification to work. And once I've got 4 points, the software can calculate the image rectification in order to check the accuracy of my control points and get some more precision information. I will assign 2 more control points, and you can see that once I have assigned 4 control points, the software helps me to find the location of the other control points. Enter, I can go back into the dialog, and here we can see a table with the deviations, and I could also exclude some with a large deviation. I could exclude from rectification process if I wanted to. Then I just need to enter a name for the rectified image. And I can select an image file format. You can see there are several file formats provided. And I would just overwrite this one, East Webinar. Go to Save and say Rectify. Yes, I want to overwrite it. And you can see calculation is pretty fast. And here we always have the control that everything fits in nicely. You can see I have done that with other parts of the facade already. So it's all in the proper location. And once I've rectified the photograph, I can add some annotations like a reference height. Oh no, sorry, cancel. I have to set the reference height first. You can select several object symbols. Could also add some text to the block. I will say OK and turn off the object set and set the reference height down here at the bottom of the facade. And then I could now annotate further height symbols, like here for the windowsill, or the windowsill over here. Okay. And if I want to find out what is the area of that of that window over here. I can also go in here with the areas annotation. If I would have drawn the outline with a polyline or something, I could use the inner point option. But now in this case, since I have not drawn anything yet, I can just pick the corner points of the area I want to measure. Right. Close. And I'll get the total area and the total perimeter. And I can insert a block by clicking OK. So I can place the block anywhere near the window, and I'll see, well, I could have typed in the name window 1, and then I get this area and perimeter annotation. I hope that's clear for so far. So let me close this one and go back to the PowerPoint presentation to show you, to inform you about several more features of Photoplan. I already mentioned that you can also rectify maps using Photoplan. It's also done by control points, similar to image rectification. The only difference is that we are using a different mathematical approach, since we have a different type of distortion when we are using scanned maps in AutoCAD. So, but the principle is the same. We do have some control points, and we do assign those control points to the image points, and the software will calculate the rectified map for us. Then you can merge photographs into a complete larger image mosaic to get one single image and make it look much nicer than this patchwork of smaller images. Photoplan does provide an automatic crossfade option as well as brightness adjustment, and you can see how it works here. And let me just briefly demonstrate this as well. So let me go back into AutoCAD. I have a different example here. Those are some petroglyphs which are scratched into the stone, and archaeologists have drawn on top of them with some chalk to make them more visible in the photographs. And you can see there have been taken several photographs in order to get a much better resolution than I would have when I just take one total photograph of all those details. And I will now just run the merge command, and I will have to add those images. Then I could shuffle down, up and down those images from the list, and I have some merging options. And for image quality, I will always select fade over and brightness correction, and then I will define the name of the resulting image and the image type, image format. I also will just select this one, and here you can see that the resulting image will be quite large, 1 gigabyte. So I will check the further settings, and we can see the resolution is very high. It's better than 1 millimeter resolution. In order for us not having to wait too long, I would just reduce this resolution to 3 millimeters. And if I say OK now, you see the size of the resulting image will be much smaller, and I just hit merge here. And yes, I want to override the image, and you can see it will just take a few seconds for the software to create the merged image, and it's of course inserting it directly into AutoCAD. Okay, let me go back to the PowerPoint presentation. I guess you got an impression how this feature is working. All we had a look at so far is single image processing, and of course there are some limitations to that. So the mathematic model of the image rectification I have just demonstrated is a plane. So we can only take accurate measurements within this rectification plane, and all parts of the object which are outside the rectification plane, they will not be projected true to scale. So this is the limitation of image rectification, which I've demonstrated. But we have a solution with the next larger module of Photoplan. With Photoplan Pro, we can do multiple image processing, and with Photoplan Ultimate, we can also calculate ortho photos, which are slightly different to the simple image rectification. With Photoplan Pro, you are able to measure true 3D points with just 2 clicks per coordinate, and in the following I will explain this process in more detail. But first, let's have a look at a summary of the features Photoplan Pro does provide. It includes all the Photoplan features I've already shown, plus tools for multiple image photogrammetry, for image orientation, etc. And also it has tools for 3D modeling and also for projecting spatially structured objects into a plane to get facade planes of very 3D structured facades. The tools that we are using to get those results are first of all, you would need to orientate images, and Photoplan does provide tools for manually orientate photographs. You would need 9 control points per image. But in addition, we also provide imports for Argisoft Photoscan images, and also for Autodesk Recap Photo projects, because those external tools, they provide a very fast and automatic way of image orientation, which we do not yet have inside Photoplan. And those oriented images, again, you need for multiple image processing, for monoplotting, and also for calculating true to scale image plans and orthophotos. So this is what you need oriented photographs for. New in Photoplan 16.5 is the Argisoft Photoscan import. So once you've imported oriented images or oriented those with Photoplan tools, you can use them to create plans of highly structured facades, like you can see here. And you can also use them for 3D modeling. One example for such a facade plan you can see on the lower left. 3D modeling example you can see on the right hand side. And how is it done? Here's a sketch on the principle. You need at least 2 images, oriented images, which do overlap, which show the same area of the object. And the symbol is here. Here you have the center of the the projection, and here you have the photographs. Those colored lines, they are representing the photo. And then you click the same point in two images, and the image rays do intersect in 3D, and this way we can calculate the 3D coordinate of this object point. So inside Photoplan, we use the physical information that when I click one point in the first image, then this same point has to be on the so-called epipolar line in the other image. And therefore we are showing the epipolar line in the second image in order to help you to find the corresponding point much more easy. So in order to make this photogrammetry tool much more comfortable, we added the new image management in Photoplan 16.5, and this will help you to easily work with multiple oriented images, and it also simplifies the setting up of viewports for the image processing, as well as it makes swapping the photographs in the viewports to be processed a child's play. And this new tool is perfectly suited for processing photos from larger photo projects such as Agisoft Photoscan or AutoCAD Recap Photo. And since demonstration helps understand much more than PowerPoints, I will go back into AutoCAD and just demonstrate the tool. We just close the drawing from the mosaic. I have an empty drawing here, and in Photoplan you will find Photoplan Pro or Ultimate. You find tools to import Agisoft Photoscan projects or AutoCAD Recap photo projects. I already did the import. I will just start the image management tool, and since I already imported the photo project, I just need to go into the folder to tell the software which folder I want to use in this drawing. And now you can see I have a list with all the oriented photographs over here. And if I want to model something in 3D or create a facade plan, I can now use those oriented images, and here we have a button to create the viewports which we need. I will just create 2 viewports over here, and I will keep one where I don't want to see the images, and I will have one where I want to see the images in a large scale to see the image, and then the geometry which I create I want to see in the foreground. So now I like to show you how to draw this outline of this window with those arcs over here, and how you can do it very quickly. First of all, I want to create a plane to draw on, and then set the coordinate system on it. So I will run this command to create the plane, and I will pick the points from multiple oriented images, and I will start with this image just to get the plane, the same plane as this one. I pick the corner over here. I have a marker, and I need to pick the same point in another image. And you can see the green line over here is the epipolar line I've been talking about earlier, and the point has to be on the same line over there. And then I zoom out. To define a plane, I need at least 3 points. I will pick 4, and let's go back here, swap it, and pick the point in there. And I get a warning message because the angle does not fit the thresholds. I would just say yes here. I will just take it anyway. And let me go back down here. I'll go back up here, draw, pick the point in the second image. All right, and do it for a fourth point just in order to show you that to have some accuracy control for the plane I am creating. Double click here, swap the image, click here, and then I can check, okay, this is, the plane is within 6 millimeters, should be okay. So I accept that plane, and let me just go in here. And what I can do now is I can set the pick the UCS, set the UCS to that plane. And you can see XY plane is now aligned with the plane I've just created. Let me go back, turn off the image here, and let me also turn off the layer with the planes and make another layer as current layer. And I will now just, since I have aligned the user coordinate system now with the facade plane of the window, I can simply use normal AutoCAD commands for drawing arcs and polylines on top of this facade. So let me just start over here. Pick a point here, pick one there, and another one here, and I have the arc there. And I could now also add a polyline, snapping here, drawing downwards here. And so on and so forth. I think you got the point. And if I now just run the extrude command, or let me swap the image, just for extrusion, it's nicer to have an image where I can see the depth more nicely. And if I want to model in 3D, I could now extrude this, extrude those things over here, more depth like this. Okay, and I have this window modeled, part of the window modeled in 3D. Or if I would have wanted to draw a facade plan, I could just draw on top of this plane, then create the next plane and draw on that one. And then in the end, I would use the flatten command over here. Okay. Hope the principle became clear. Finally, the largest software package of our Photoplan product family is Photoplan Ultimate. This one includes all the features of Photoplan Pro and Basic and the smaller packages, and adds functionality for creation of auto photos and functionality for creating image plans by unwrapping photographs into a plane. How does that look like? We in an orthophoto, the central projective distortions are removed, and this way they are usable as image plan. Everything which is parallel to the image plane, which is here, will be true to scale. So everything on this facade will be true to scale except those curved parts. Therefore, if you have a curve feature and want to measure true length on top of this cylinder or in the unwrapped image, then you would need to use the unwrap command rather than the orthophoto command. And here is how this works. You can create image plans by unwinding the photos into a plane. You can, here's just some examples of different shapes which we can unwrap. So you can unwrap photos of towers, walls, facades, ceiling paintings, and much more for a detailed evaluation based on the resulting raster image and for picking true lengths inside the resulting raster image. And once more, I want to give you a brief demonstration of the photo plan functionality. And I have prepared an image with a cylinder as the surface. You can see there is we've captured photographs of a cylindrical tower. We did use the cylinder fitting commands, and we have measured a few points on the facade in order to orientate the images, and we can use those measured control points to fit the cylinder. I've already prepared this, and then we can use those photographs in order to create an unwrapped image plan of this tower. And I want to show you that you can also clip oriented images, because I don't want to unwrap the sky or those leaves over here. So I will clip the image first before I start the unwrapping process. And you have to be aware that only those parts which are lying directly on the ideal cylinder will be presented in true length. Everything else will not be. All right, so we have clipped the images. We have the cylinder as a projection surface, which we then unwrap, so I can run the command. So I'll select the cylinder, and the photographs are on the outside of the cylinder, and I will define a reference point over here for me to make it more easier to define how far left and right of this reference point I want to unwrap. I don't have photographs from around this tower, so I don't want to unwrap the complete perimeter, just a part, just a small part of it, because my photos only cover a small part of this cylindrical tower. And I will add the photographs. I could shift them up and down. I have overlapping options, best angle, etc. I can also apply brightness correction, and I need, of course, to tell the software the name and the format of the resulting image. I'll once more take this one and override it. Further settings we can check. Resolution should be okay. Now we can compute the projection, and again it takes a few seconds for the software to calculate this new unwrapped raster image, and it will be shown placed at the location at the cylinder over here. So if I say yes, okay, and the the software also sets the user coordinate system to this image now, so I can directly go in here and take some dimensions, measurements, like here. And let me pick another one over here. Okay, let's do another one for the vertical dimension of this window over here. So this is what you can do with unwrapping. Just for comparison, if I don't unwrap and rather create an ortho image of this tower, you will see that the measurements over here for the window, they are much shorter, especially even for a short length like this one. It's now only 0.59, while when I really unwrap, I get the true length, which is 0.69. So it's 10 centimeters difference from the ortho image, which doesn't show the true length, to the unwrapped image, which does provide the true length of the object here. All right. Finally, let's talk about accuracy and precision, because that will be interesting for you as well. Accuracy and precision of the results do depend on, first, the number, composition, and of course resolution of the photographs you are taking, and as well of the accuracy and the distribution of the control points you are measuring with your total station. So these things are very important and influence the results. So let me summarize. Photoplan product family does consist of 4 modules. The smallest one is Photoplan Basic. Then we have Photoplan with image rectification, rectification of maps, merging of photographs, and each box does contain the smaller box. So the next larger one product is Photoplan Pro, which adds image orientation and photogrammetry tools. And the largest box does contain all of the smaller boxes. It's Photoplan Ultimate, and it adds tools for creation of true ortho photos, as well of true to scale image plans by unwinding various shapes into the plane. So you get, with Photoplan, you get accurately rectified images inside AutoCAD. You can combine high-resolution photos with CAD information. You can apply photogrammetry for creation of 2D plans and 3D models. You can quickly construct vector graphics. You can do area calculation on top of photos. You can do calculate lens distortion correction. You can apply it during rectification process. You can merge images to a mosaic. You can create ortho photos and unwrap photographs to create image plans. The training curve is very low, so it's not hard to learn how Photoplan works, and it's usable in multiple fields of application. One last thing is, what you might be interested as well, is the compatibility of the new version of Photoplan. Photoplan 16.5, released just half a month ago, is compatible with following operating systems according to the system requirements of your version of AutoCAD. It will run with Windows XP 7, 8, 8.1, and soon it will also support Windows 10. And the current version does support AutoCAD and AutoCAD LT in the versions 2013 to 2016. But of course, if you have older AutoCADs, we can make earlier releases of Photoplan available if you need to run them on older systems. So thank you for your interest. I will now check if you have any questions or typed in any questions during my presentation. I will now go in and answer them. So let's have a look at the questions. See if there are any in the chat log. Okay, there's a question from David Wells. He's asking how accurate is Photoplan, or how is accuracy measured? That's a good question. I had one slide which explains what accuracy and precision depends upon, but Photoplan does offer also offer accuracy checks. I don't have an example. I've closed that drawing already. During image rectification, you have quality check with the control points which you assign, and during multiple image photogrammetry, you have accuracy information in the image management tool. If you have a look at the lower left bottom left, there are values for average distance, maximum distance, and maximum angle between the image rays. If you are using more than 2 images for calculation of the 3D point, you always get those accuracy values displayed down here. I hope that answers your question, David. I will check. There are more questions coming in. I think we have another 5 minutes for answering questions. Okay. So if there are no further questions coming in right now, you can feel free to, if any questions occur afterwards, you can just write an email to info@faro-3d-software.com, and we will be happy to answer your questions by email. So thank you once more for your attention, and you will receive a follow-up email later on with a link to the recorded webinar, so you can share it with your colleagues. So bye-bye for now, and I will stop recording.